Okay, in the last two problems of this test 3 review handout, we have comparison inequalities between rational expressions. And for 13 we have 2 over x minus 5 is less than 1 over x plus 1. And if I convert this inequality statement as one that involves the comparison to 0, so I can just subtract 1 over x plus 1 from 2 over x minus 5 and combine these rational expressions. So just sort of stepping over to the side, if I take 1 over x plus 1 away from 2 over x minus 5 and consolidate, we have making into one expression that has a common denominator, and the least common denominator will be the product of x minus 5 times x plus 1, and writing each of the expressions in terms of the least common denominator. So for 2 over x minus 5, we have the x minus 5 factor, but we're missing the x plus 1. So multiplying this ratio by 1 in the form of x plus 1 over itself. I'm going to have first ratio in terms of the least common denominator. And then for what we have with the second ratio, which we have at 1 over x plus 1, which will be subtracted, but writing in terms of the least common denominator. We have x plus 1, but we're missing the x minus 5. So multiplying the second ratio by 1 in the form of x minus 5 over itself. We have in the next stage, so for 2 over x plus 1, that would be 2x plus 2. Then we had the subtraction, what is going to be the subtraction of the quantity of x minus 5. And we have distributing subtraction. So we have again 2x plus 2, and taking the subtraction of x minus 5, x becomes negative, minus 5 becomes positive, and we have the activity going on over the least common denominator. And combining the numerator terms, we have 2x minus x becomes x, and we have 2 plus 5 is 7. So the consolidated ratio, we're going to have it x plus 7 all over the quantity of x minus 5 times the quantity of x plus 1, and we have to be less than 0. So we have with the consolidated ratio, if we identify the zeros, from x plus 7, I have negative 7, and from the denominator factors, from x minus 5, I have x at 5, from x plus 1, I have x at negative 1, and again, you can have, for r of x, you can have 0 in the numerator as long as you do not have a 0 denominator, but you cannot have a 0 denominator, period. From x plus 7, I have negative 7, and since this factor is exclusively in the numerator, and since negative 7 does not result as a 0 denominator, negative 7 will be in the domain. However, with 5 and negative 1, those values will not be in the domain of r of x, since we have these to stem from factors located in the denominator, again, which cannot be equal to 0. And setting up a table of intervals revolved about these zeros. So we have those values from negative infinity approaching negative 7, which is the smallest of the 3 zeros. Then we have bypassing negative 7 approaching the next smallest 0, which is negative 1. And then we have bypassing negative 1 approaching the last of the zeros, which is 5. And the last interval you will have to be those values of x greater than 5. And applying tested values, anything less than negative 7, negative 8 qualifies as a sample. Anything greater than negative 7 and less than negative 1, we have negative 2. Between negative 1 and 5, we have 0 as a possible sample. And anything greater than 5, we can go with the number 6. So if I take each of these values as x amounts into what we have for our consolidated r of x, what's going to happen here is that for negative 8, as the input, the resulting output will be at negative 1 over 91. Testing out negative 2, this will result as a positive 5/7. If I plug in 0, this will come out to a negative 7/5, and plugging in 6 for x, this will come out to a positive 13 over 7. And for what we have for the sign value of r of x, Okay, so we have first interval, anything you plug in less than -7 results as a negative output. So we have r of x is less than 0. Anything greater than -7 and less than -1 results as a positive output, whereupon we have r of x is greater than 0. Anything greater than -1 and less than 5 for the input results in a negative output. So we have r of x is less than 0. And anything we plug in greater than 5 will result as a positive output, again, whereupon we have r of x is greater than 0. Okay, so we have for what we have in the problem. Okay, so we have with taking what we have in the comparison inequality. Again, we had 2 over x minus 5 is less than 1 over x plus 1. And after converting what we had as a comparison to 0 inequality, again, we had x plus 7 all over the product of the quantities of x minus 5 and x plus 1. And where we have, again, to be written, whereupon this consolidated ratio is less than 0, and you have whereupon r of x is less than 0, and that feature is going to be in both the first and the third subinterval sections. Okay, so where r of x is less than 0, you have for those values of x less than -7, and also we have to exist for those values of x greater than -1 and less than 5. So we have these two interval solutions for number 13. Now, for what we have in the case of number 14, okay, so we're looking at another comparison inequality. Now we have, in this particular case, we have 4 over x plus 2 is greater than or equal to 2 over x minus 2. And if I were to write this as a comparison to 0 inequality, so again we have combining these ratios. So if I were to take 2 over x minus 2 away from 4 over x plus 2, again combining into a single ratio, we have to acknowledge the least common denominator, which will have at the quantity of x plus 2 times that of x minus 2. First ratio, we had the x plus 2 factor, but we're missing the x minus 2. So the first ratio you will have multiplied by 1 in the form of x minus 2 over itself. And as for minus 2 over x minus 2, for 2 over x minus 2, it has the x minus 2 factor, but it's missing x plus 2. So to make the adjustments, we're going to multiply this ratio by 1 in the form of the missing factor divided by itself. And looking at the distribution, so we have 4 over x minus 2 is 4x minus 8. Bring down subtraction, and I have 2 times the quantity of x plus 2. And we have all over x plus 2 quantity times the quantity of x minus 2. And we have with the distributing, okay, we have 4x minus 8 minus 2x minus 4. And combining the numerator terms, we come out to 2x minus 12 all over the product of x plus 2 and x minus 2. So we have, in combining, okay, we have our original inequality statement written in terms of comparison to 0. So we have 2x minus 12 all over the product of x plus 2 and x minus 2. So we have for the consolidated ratio, if I were to set the numerator to 0, the x value will be at 6. And for the denominator factors, for x plus 2, x is equal to -2. For x minus 2, we have the x is equal to 2. And again, you can have a 0 numerator as long as you do not have a 0 denominator. And we have from the numerator, I have 2x minus 12, from which I have 6. And 6 does not create a 0 denominator. So 6 is going to be in the domain of this rational expression consolidated. However, in the case of negative and positive 2, those create 0 denominator values. So neither of these amounts will be in the domain. And again, setting up a table of intervals. Okay, so rank ordering from smallest to largest. So I have going from negative infinity approaching -2. Then I have going past -2 approaching 2. Then bypassing 2 approaching 6. And then we have those values of x that will be greater than 6. And again, taking on test values of x. So we have -3 to be a value less than -2. 0 exists as a test value between negative and positive 2. And 3 we have to lie between 2 and 6. And 7 we have as a value that is greater than 6. And we have just for the outputs, Okay, so we have with -3 as the input, the output is -18/5. Next we have with 0 put in, the output is going to be a +3 once you simplify. And then we have for the input 3, okay, the output comes out to -6/5. And we have with 7 plugged in, will come out again in terms of the ratio, this will end up becoming a +2/45. And for what we have in the case of the sign value of R of X, again, anything you plug in less than -2, we want to have a negative output, so we have R of X is less than 0. Anything we plug greater than -2 and less than +2, we have a positive output, whereupon we have R of X is greater than 0. And then we have anything greater than 2 and less than 6 for the input. The output is going to be a negative. Again, R of X is less than 0. And anything beyond 6 that is plugged in for X, the output will always be positive. And again, we have R of X is greater than 0. And in looking at what we have going from the comparison inequality to our combined ratio in comparison to 0. Okay, so we have for 2x minus 12 over x plus 2 times x minus 2 is greater than or equal to 0. So we have as our first priorities, we're looking at where R of X is greater than 0. So we have between negative and +2, and also going past 6 on out to infinity. And for the enclosures with the equal sign, there is the possibility, but not guarantee, of there existing a bracket. Now, for negative and +2, okay, now I cannot make negative or +2 create a situation where this ratio is equal to 0, because negative and +2 creates a 0 value denominator. Neither one is in the domain, and so we have parentheses to go around these amounts, and only the value 6 will officially make R of X equal to 0. So this will make the equal to 0 part possible. And since 6 is in the domain, okay, we had that to be in the bracket. And again, infinities are boundless. And so for what we have in this overall statement, this will be the solution set for what we have for this comparison inequality.